Hey, okay, there are some people out there. Cool. So welcome. Thanks for coming to my session here on securing web apps and APIs for ASP.NET Core 2.2 and 3.0. My name is Brock Allen. I call myself an application security architect, I guess. I do consulting for a company called Alliance, and I basically help my customers with their identity and access control. So basically that means figuring out how to get users authenticated, managing passwords, doing multi-factor authentication, very often single sign-on, apps calling APIs securely, and authorization. And a lot of that revolves around a protocol called OpenID Connect and OAuth 2. And so as part of that, I actually work on an open source project called IdentityServer. I do some other open source projects as well, but IdentityServer is probably the best known. I've been doing, security for a long time, and ASP.NET and .NET for even longer. And so, kind of speaking of the good old days, right? How many of you have been around long enough to remember what this is? Anyone? Okay, the folks with gray hair or no hair? Yeah, absolutely. Okay. So, curious question: how many of these settings actually work? I'll give you a hint. None works. Okay? Well, forms authentication, that worked, right? A lot of people will build ASP.NET apps and use this cookie-based approach with forms-based authentication. That one worked. Windows authentication worked. That was basically saying, do whatever IIS does. And that mainly was because you were looking to do Windows authentication, for your users, because they were in Active Directory. But when .NET 1.0 was being released, they were trying to ship a product called Passport, which is actually different than whatever the new product in the last year or so called Passport is. I've been around long enough. When they start recycling product names to something totally different, it makes me feel old, I guess. Anyway, Passport is something that everybody flipped out. They didn't want, and it was a product that was cut, but Microsoft didn't update the enum. So it just hung around, and it just never did anything, okay? They actually tried to do this again when, I think it was 4.5 was shipped of ASP.NET, and they tried to do a new federated authentication model. And so that product also didn't ship, but they forgot to update the enum, okay? So anyway, don't choose federated or Passport. They're not going to work. So the point of this talk is to basically talk about modern applications, right? The kind of apps we're building are very different than they were back in the ASP.NET days. And what we're looking to do is figure out how to, this talk is for people who are potentially new to ASP.NET Core, or maybe you've been using ASP.NET Core, but you haven't really looked into the security features. And it's meant to give you an overview of the features in this framework to basically be able to architect these modern style applications. So the modern types of apps that we're building a lot of back-end web APIs, right? The assumption that those are basically HTTP-based APIs. And then we're building a lot of front ends that are then calling the back ends. The types of front ends we're building, though, are actually quite a few, right? We're building your traditional server-side web app, right? Think of MVC, right? That might be calling an API. But of course, you have a user using it, and you want to do authentication and things like that. So there's that type of app. We also have JavaScript browser-based applications, SPAs, using Angular, React, or whatever. And those, of course, also want to call APIs securely. We're building mobile and native apps too, right? Either your iOS or Android app, or even a desktop app that you might install onto Windows or Mac. And those also want to authenticate a user or call a web API. And then also you have server-to-server types of scenarios where you want to call APIs securely, but there's no user using the app. So that's kind of the point of this session, is to show you what is available in ASP.NET Core to secure this type of architecture, okay? And so here's the list of things we're going to look at. And of course, to get started, it makes sense to start at the starting point, which is the hosting layer. So ASP.NET Core, when it was first shipped, came with a web server called Kestrel. And the whole architecture was that an ASP.NET Core application, when it loaded, was just a console app, but it had embedded inside of it this web server called Kestrel. And so when 1.0 of ASP.NET Core was released, they basically said Kestrel is not approved to run publicly on the internet. Okay? And what that meant is in your architecture, you had to stick a reverse proxy in front of it. So you had to stick IIS or Apache or Nginx in front of your ASP.NET app. And the intent there was because Apache and all those other web servers were basically battle hardened, right? They were basically, well tested and very mature in dealing with, the vicious internet, as it were. okay? And then you basically would reverse proxy back to your actual console app on the top right there. When 2.0 of ASP.NET Core came out, they certified Kestrel to run publicly on the internet. So they actually did a whole bunch of penetration testing. They found bugs, and they fixed them. And they basically figured out that, okay, great, we think we've run this through enough tests, and we know how it all works well enough that we will support this if you want to stick this on your edge, okay? Personally, I'm not sure I would do that yet, okay? It's still kind of a new web server. So at least for me, being a little bit more comfortable, wanting to have enough layers of security in there, I probably still would advise the reverse proxy approach, even though it's officially supported, okay? But in terms of what the modern features are in Kestrel, to be an edge server, you absolutely have to support HTTPS. So that's absolutely supported in Kestrel. You can do, sort of the static-based certificate mapping, host mapping to certificate, or it even supports the more dynamic server name indication, which is where you can set up like a wildcard cert, and your HTTPS host could listen for multiple domains, which is kind of nice. The other nice thing about Kestrel is that during development, you can actually use HTTPS during development. They have some nice tooling around that to do, like local host, but HTTPS. So it's good to get in the habit of, testing with HTTPS, because there are things you miss during development that you kind of only find out about once you push to, well, hopefully not production, but at least, QA and testing. If you do want to run Kestrel on the edge, then there are a bunch of default settings with how it deals with incoming, network traffic from a security standpoint. But you need to be aware that these things are configurable, and you may have to, depending on what your app is doing, get familiar with some of the low-level configuration settings, like the number of inbound requests that can be accepted, what the request queue is going to be, what the timeout is going to be, like when bytes are being sent in. If the bytes are being sent in too slow, that might be an attack, and so you need to know what your cutoff limit is going to be. And when bytes are being sent out, are they not being read fast enough? And all these like little low-level kind of like what a network admin might be thinking about. So anyway, that's the thing, is if you are taking on this responsibility of running on the edge, be prepared to get really, really familiar with this stuff, okay? Okay, moving along in the stack then is once you have your console app up and running in ASP.NET Core, you're going to be running in, loading in ASP.NET Core and running in Kestrel, which opens up your, in-memory web server listening on some socket. The whole architecture then of ASP.NET Core is that when requests come in, it invokes this middleware pipeline. And the middleware pipeline is basically the component model of processing requests in ASP.NET Core. Middleware is like the reusable component that might do logging or exception handling or serving up static files or security, mind you. Okay? Also, MVC or application frameworks like MVC are typically packaged up into middleware. And so the order of this pipeline is very important because that's the order that your code will run in processing the requests. So since MVC very often is going to be rendering the response, you kind of put that at the end of the pipeline so that when requests come in, your middleware up front get to do their, whatever job that they're doing to, build up whatever your web server is doing. The other big thing about ASP.NET Core is the whole service architecture with dependency injection. So any services that are needed during the request processing are configured in the DI container. Okay? So you build this middleware, you put the middleware in that you need, you put the services in DI that you need, and you're up and running. When it comes to security then, most of the features of security from ASP.NET Core are in the DI container. There has services that are available as your request is being processed. There are a couple of middlewares. One middleware is for authentication, and there's another middleware for cores. But in terms of most of the functionality, it's mainly provided out of services. So in terms of the services, the first one that actually I think most people probably, well, put it this way, it's not a very visible feature in ASP.NET Core. So it's something, though, it's one of those things that you maybe find out about when you do go to production because it didn't show up during local testing, and that's something called data protection. Okay? So in terms of sort of going back in the Wayback Machine again, do you guys remember this from ASP.NET? The old machine key element? What was it for? Say again? To encrypt my web config? No. But it is to encrypt something. Yeah, encrypt cookies, okay? So data protection was a feature of the old ASP.NET, or classic ASP.NET, I guess as we call it now. And so basically, your web application will be generating values that are going to leave your web server, okay? And then later on, that value is going to be sent back into your web server. And when it comes back in, you want to make sure that nobody's changed it or modified it or tampered with it. So data protection was a general feature that basically allowed you to pass a value in, and you got back an encrypted and a digitally signed blob version of that value. And then you could send it out. And that's a perfect thing for a cookie, right? Because when you send a cookie to the browser, right, if it says role admin, you don't want the user changing that string in the cookie, okay? So when it's sent back in, data protection could, validate the value and decrypt it, and you get back the original value, okay? So of course, that involves cryptography, and cryptography requires key material, and that's what that key material is. So this is now gone in ASP.NET Core because we were all doing this wrong, okay? Basically, people would go to Google to figure out what keys they should put in here. That's not a good idea, right? You're talking about key material, it should be private. Very often, well, actually, where is this file located? This is the web.config file, right? That's in the root of your application directory. So when requests come in, like that file's just sitting there along with the rest of the application code. So if you had bugs in your app, maybe somehow a vulnerability that would read your config file, this would spit it out to the end user, right? There's a nice little Google search down here, right? So you might, somehow leak this key. Also, people accidentally check this into their source code repository, right? And, it shows up on GitHub, okay? So this is just generally a bad idea. So data protection does exist in ASP.NET Core, but it's completely re-architected to solve some of these problems that we've had. Okay? So the first one I think is more important, which is the second bullet, is that the keys are automatically generated for you. You don't have to know anything about the crypto algorithm or how to generate the key. It's just dynamically generated for you. And then that key is used to do the protecting of cookies and other things, okay? Now, the other thing is that the keys should be stored outside the application directory. So you have a few options about where you store this. But this is the thing that most people don't or aren't aware of, is that you actually have to participate in this. You have to be, think about this, realize that you are responsible for thinking about where to put these. All right? The reason that that's important is because in a load-balanced web farm environment, the two different servers have to have access to the same keys so that they can read and decrypt each other's cookies. Okay? Now, if you're running in Azure, magic happens, right? It just works, okay? But if you're not running in Azure, you're doing your own hosting, then you need to explicitly configure this to some shared location that both or all of your web servers have access to. So, there's some implementations for like Redis and the database and other things like that. But basically, this is something a lot of people don't see in development. Then you push to production, load balance servers, your cookies don't work, okay? Or at least they work half the time when you go to the right machine, but not the other machine. So I have a demo here. So what I have is just a pretty simple ASP.NET Core application. Here's my startup code, and here is the configuration for data protection. And it's just showing you how you can add in data protection. When you're setting up data protection, you can give your application a name. What this does is the data protection key is like a master key, and then they derive a key that is private to your app, and that name affects that sort of private key. And then what we're basically doing is saying, okay, I want to persist these keys to the file system. And don't do this because I'm putting it in my application directory, but this is where kind of you would say, oh, put it in this folder, on the server somewhere. Microsoft basically is expecting you to put in a UNC path if you're doing your own, multiple server deployment kind of thing. So you would put it in a network share, for example. Now, if you don't want to set up a network share, then you can implement this interface called iXML repository that is the actual interface that reads and writes from the store, and then you can go stick the thing in a database or Redis cache or whatever else you want to do, okay? The one gotcha about this is, though, when you do write these out to the file system or to the Redis cache or to the database, then the keys will be in plain text. So anybody else who have access to that network share or whatever can, read those keys. So there's one last thing you typically have to do, which is you have to think about how to encrypt the keys that are at rest. And so Microsoft has a few features for this. One is, this was actually not going to work in a load balance environment, but DPAPI is a Windows-specific way to do protection of the keys, but it's Windows-specific for the current user. So this is not really going to work in your load balance environment. The other thing they have you do is protect keys with certificate. And what you would do is you would pop in an X509 certificate here, and then that's what you end up doing is you take a certificate that has the private key that's going to protect all your other keys, and that's what you distribute to all those servers in your web farm. So now this certificate kind of becomes a replacement for this thing that you used to have her synchronize across all the machines in your web farm, okay? Okay, so I'll leave that back here. So what I'm going to do is I'm going to run this, and again, I'm storing this in the current directory. And I know you can't see it, it's not here, there's no text file with this key material. So what I'm gonna do is run this, and what we should see is when this app starts up, there we go, this key got created. So if we pop this open, we'll see that this is the actual key is stored inside of this XML file. This XML file has information about when the key was created, right? When it should be activated, when it should be expired. Okay, that's actually an interesting feature of this, is that the key that it creates actually has an expiration. So after 90 days, by default, a new key gets created. That's kind of like good key hygiene. You do key rolling, okay? So it's kind of nice. You'll see then multiple keys over, months and months and months start to accumulate here. And then here's the actual key material. And because it's on plain text, we don't want it visible to everybody, so we've actually then done further encryption of it, in this case with DP-API. Again, that won't work across servers. You'd use a certificate approach. So I'm going to run this application. Oh, actually, I'm already running. And the job of this application is actually to use the data protection API. So what I'm going to do is type in, hello NDC, okay? And I've now encrypted that value. So if you had your application and you had some value you wanted to send as a query string to another page in your app, or you had you're building a wizard where you're building up state and doing like postbacks across multiple steps of a wizard type of thing, and you wanted some data to persist across those, but you wanted to make sure nobody messed with it, this is exactly what you'd use, okay? Now, what I'm going to do, just to show you that this key material is important, I shut down my server. I'm going to go delete the key file, okay, which I should, there we go, close that. I'm going to rerun my server, okay? A new key got created, so there's a new key there. And now if I try to unprotect the same value, it fails, right? Because the key that was used to protect is not now the same key to unprotect, therefore crypto fails, right? And you get an exception that the unprotection layer fails. Okay, just to show you that there in fact is, ciphertext and other looking keyring looking crypto things. All right, so anyway, that's the point of that. Okay, questions about that? Right, so the question is about the key rolling, and then what if I create a cookie that's protected with the first key, and then at that moment a second key gets created, well that cookie's still unprotect. And so the key rolling is for new protections, but all the prior keys are possible in the key ring for unprotections. So they keep around the old ones. So that's actually a good point, is that if you are going to build your own database or leave this on the file system, keep the old ones, right? Don't throw those away. Or rather, the ones that you can throw away are the ones that you are guaranteed that you don't have any still outstanding unprotected data, right? Keys from 2 years ago, probably good to throw away. Okay, cool. That's what the key file looks like. This key data protection feature is used actually several different areas in ASP.NET Core. It's used in the cookie stuff that we just talked about. So when you are using an authentication cookie, right, that's a very important cookie, that needs to be data protected. If you're using the anti-forgery feature in ASP.NET Core, which pretty much anybody with a postback is, that is using the data protection to derive that. If you're using OpenID Connect or Google logins or anything else, you're making round trips out of your app over to Google and then back, and there's data that's round tripped as part of that. That needs to be protected as well. If you're using the temp data feature in MVC, where you can put like a little message in a temp data and then a redirect to the next page and read out the temp data, that gets put into a cookie, and it also needs to be protected, basically for integrity checks. And as I mentioned here in my little demo, I actually didn't show you the code, I probably should have, but you can use this yourself directly. So you inject into your controller constructor arguments the data protection provider, you create a protector, and then you can use the protect and unprotect methods. Okay, pretty easy to use. Yeah, question? You're passing a what page to page?
Like an ID.
An ID, okay.
Will you use this pass checksum with that ID?
So, so whatever the data is, let's not focus on an ID, but whatever the data might be, you actually protect the data, and it gives you back that gobbledygook I showed you in the demo, and the gobbledygook is what you send over to the next page. So the gobbledygook has the original value and the checksum all lumped into one. Make sense? Okay. Now, you saw it was big, right? That's the cost of doing the encryption and the digital signature. Okay? But you have integrity, so that's pretty darn important. Okay, the next service that we need to talk about in ASP.NET Core is the authentication service. This is basically the infrastructure that allows a user to log into your system. And so there are actually lots of different options here, lots of features that Microsoft provides. One is obviously local authentication, so a user can just walk up to your app, enter a username and password, and get logged in. They also have support for social logins, so Facebook and Twitter and that kind of thing. Microsoft only provides 4 out of the box social logins, but there is a contrib project up on GitHub that has about 50 more. So Yahoo, GitHub, Battle.net, right? If you want to log in with your Warcraft account. Untapped if you do the beer drinking app, right? And you need to use that to log in. All the important ones are there, okay? So basically, you can use social logins to get into your app. Microsoft also provides more enterprise-grade authentication support using the standards like OpenID Connect and WS Federation. So that's actually really important with enterprises or even your own, Azure Active Directory logins where you want to be able to, send the user up there to log in, and then they come back to your app with their identity from that identity provider. SAML2P is another very popular, not so much in the Microsoft space, but more in the Java space, protocol. It is not supported by Microsoft, but there is another open source project out there by a guy named Anders Abel from SustainSys. He builds this SAML provider that fits right into ASP.NET Core. So that's actually great, easy to use, and it works well. There's also support for JSON Web Tokens. That's basically if you're going to be doing API security with a token. So there's support that Microsoft has for that as well. Okay. And then no matter how you're going to log in, at least with one of the interactive options with a user, you need to manage the authentication session for that user, which is basically backed by a cookie. So there is a cookie component that will help you manage that. Okay? The way the authentication system works in ASP.NET Core is that there is a service in the DI container, and then what you do is you register handlers, which are like there's like a micro framework. So there are these handlers that will do the specific ones that you want. So there's a handler for Google, there's a handler for Facebook, there's a handler for cookies, and so on and so forth. So what an example of setting up an application would look like is that in your DI configuration, when you configure services, you would call add authentication, that adds the general authentication services. You then add cookies, Google, and OpenID Connect, because those are the particular handlers that this application wants to use. So you want to do session management with cookies, and you want to allow the user to go to Google login, and you want to allow the user to go to some OpenID Connect provider to log in, okay? Whenever you register these handlers, you give them a name, and that's that scheme that's associated with each one. That's so that in your application, when you want to talk to one of these guys, you talk to them via the scheme name, okay? It turns out you actually don't talk to them directly. You're required to go through this service called the authentication service. So this is like an orchestrator or an abstraction over those handlers, and it provides you sort of a consistent API for the types of things you would want to communicate to the handlers, okay? So the first method is something called authenticate async. This basically says, I want to read the incoming request and know who the user is, okay? Now when you call this basically says, I want to read the request. So that's perfect for a cookie, right? Imagine every single request coming in, you're going to read the cookie. Now you don't want to write that code in every single one of your action methods or whatever. So a very typical pattern is you would put a piece of middleware in the pipeline to sit in front of the rest of your app to do that. And that's exactly what the authentication middleware does. It's its sole purpose in life, well, for the most part, but its primary purpose is to call this authenticate method up here. And what it does is it calls authenticate. Now there is a parameter called scheme, and it basically says, hey, I want to read the request because I want one of these handlers to trigger. Now, we know that it's really the cookie that we want to read on every request. So I didn't use any kind of configuration down here in the use authentication, so which of the 3 handlers runs, right? Well, you can pass null for the scheme, and if you do, what you're saying is you would like whichever one you've marked as the default to run. So basically now, on every single request, use authentication calls the authenticate method passing a null scheme. The null scheme means, oh, use cookies. We go to the cookie handler. We let hit do his job. It reads the cookie. If the cookie produces a valid user, then the authentication middleware sets the user on the HTTP context. So now the rest of the request in the pipeline has a user object, okay, if there was a cookie. And it validated because of data protection. Okay, the other methods you can call here, sign in and sign out, are the 2 methods for doing authentication session management. Sign in basically says create a cookie. Sign out says delete the cookie. Very simple, right? So if you're building a login page, well, after you've validated a password, you'll call sign in. If the user clicks sign out, you'll call sign out. Challenge is the method that says, hey, you know what? The user's anonymous. I need to redirect them to go log in, okay? So the scheme is a very important parameter here because what it does is it identifies, oh, do I want to send them to Google or Facebook or OpenID Connect or whatever? So that challenge method basically kind of lets you, indicate which one to trigger. If you happen to trigger cookies, well, cookies is your session management, but it also kind of has the notion of saying, oh, I need to go get the user logged in, but the assumption is that's a local login, so you would need to configure what local URL or what path in your app is going to have your login page. Okay? And forbid is the last method, and that basically says, hey, I know who the user is, they're just not allowed to be here. Okay? And so forbid generally triggers like an error page or an access denied page. There are a bunch of extension methods on the HTTP context to wrap that up to make it more convenient. So I'll just leave those there. And here's an example of an application that is just doing cookies, for example. So the idea is that maybe I'm just doing local logins. So I've configured authentication. The default scheme is cookies. I only have a cookie authentication handler. And notice I'm configuring like the login path. So when we call challenge on cookies, that will redirect the user to the local login. Then you can configure the aspects of the cookie, like the name of the cookie, how long you want it to be, does it slide, does it have the same site flag? And then, how do you talk to the cookie handler to actually issue the cookie or get rid of the cookie? Well, this is what something like your login page might have. So once the user has entered a username and password, what we will do is look them up in the database, validate the password, okay? Now how we do that? Well, again, that's up to you. I'm going to talk about ASP.NET Identity in a minute, which is the Microsoft library for doing that. But actually, this is a very important distinction. That library, identity is how they call it, or ASP.NET Identity, that's unrelated to actually what I'm showing you here, right? I mean, you probably use them together, but strictly speaking, you don't have to use that. This is the code it takes to just get a user logged in, regardless of where you keep their password. So what we do is we create a list of claims. This is modeling the information about the user that we care about. So sub is usually the user's unique ID, subject identifier. And then we also say, oh, I know, it's Bob, so I'll set the name claim. And we create a claims identity class. And then down here at the sign-in call, we pass that in. And those claims basically become the information that's written out to the cookie. So now our cookie contains the user's unique ID, 123, and their display name Bob, so you can show it later. So your login page has to decide what claims you want to basically serialize into the cookie. Now when you issue a cookie with ASP.NET Core, the authentication cookie, the cookie has the claims, which is the information about the user, but it also has this other section, which is like a dictionary, and you can just put arbitrary other metadata if you want in there. And so that's what this authentication properties is basically you can stick whatever you want to in this items collection. That will also get written to the cookie, okay? And then you can read that out later for whatever you might need. That's actually how internally they keep track of like the expiration, right? You're supposed to expire, the cookie's supposed to expire in 20 minutes. They actually internally use the same dictionary. The sign out method at the bottom here is actually then what we call to delete the cookie. Okay? All right, good. There are a few other features on the cookie handler. Actually, all the handlers have this eventing model where when sort of interesting internal processing is occurring, they'll raise an event. And so for the cookie, a couple of the interesting events are, so the cookie comes into your application. The authenticate gets called because we have the middleware. The cookie will read the cookie handler will read the cookie, validate it with data protection. Everything looks good. And then it will raise an event, which is called validate user, right? Basically gives you a hook after the cookie's been checked out to see if you actually want to accept the cookie or accept that request from that user. Gives you a chance to maybe like look up in the database, right? The cookie says it's Bob. Well, you look up in the database to maybe see if Bob's really been deactivated. Then you can reject this so that the cookie's not actually trusted. Okay? There are also events around redirecting for sign-in, redirecting for sign-out, and so on and so forth. Now, one of the other things about the cookie handler that's good to be aware of is, remember I said that we can put claims into the cookie, we can put this arbitrary dictionary with arbitrary data. Well, that's going to make your cookie bigger and bigger and bigger the more stuff you put in there. Okay? How big can your cookie be? Well, it depends. That's the consultant answer, of course. Do you have to? The real question is this: do you have to support Safari on iOS? If the answer is no, then you have a lot of space in that cookie, like 16K of data. Okay? If you have to support Safari on iOS, then you have very, very little space. Your entire domain has to have less than 4K of cookies. And it doesn't take long to get up there, okay? So that's not just one cookie, that's all the cookies. So Safari on iOS will just start throwing away cookies randomly, and the user all of a sudden will be, like logged out, okay? So how do you mitigate against that? Well, you can, instead of serializing all those claims in that dictionary into the cookie proper, you can actually implement a storage mechanism that stays server-side. Okay, but that means you now have to have a database that puts the blob of data, and then what gets written to the cookie is just an identifier. Okay, so at least it'll make the cookie a lot smaller. That's kind of cool though, actually. I like that feature because it allows server-side revocation, right? Let's say your admin decides, hey, that user, right, I'm going to kick him out of the website. Well, how do you go to that user's browser and delete their cookie? Yeah, it's not going to happen. So, but you can delete the record in the database, and now the cookie won't match, right? And they will be considered anonymous. Okay, cool. Another feature then of the authentication system is this concept of external authentication, right? Being able to do a password in your app is great, but it's better if you don't have to deal with passwords, okay? So the architecture that we tend to move towards is getting credentials out of your app. Your app instead trusts something else to log the user in, usually some sort of single sign-on server, okay? So you could trust something like Google, or you could trust Azure Active Directory. You could build your own, very, very common pattern, okay? And the basic workflow is this. When the user indicates that they want to go log in with the external provider, that's what you call the challenge method. And challenge basically triggers whichever handler, Google, Facebook, OpenID Connect, and it redirects the user away from your application, okay? They're gone from your app. So that's an interesting workflow, right? You're used to having the user redirect all within your app. They're now gone, and you don't know when they're coming back. Hopefully it'll be soon, right? But you don't know. So the workflow then is that they're gone from your app, they go to Google, they log in, and eventually Google redirects the user back into your app to what's called the redirect URI, or there's a callback path in your app, and it's sort of the dedicated landing place for the user after Google, okay, or after Facebook or whatever. And your app has to continue processing from there as if the user, is still in the middle of their login workflow. Usually that's all handled by the authentication handler, so that's good, but yeah. Okay, so here's an example of what that would look like to use OpenID Connect. So OpenID Connect is a protocol for authentication. It allows the user to go to a different identity provider to log in, and then your app can get the result of that, and your app doesn't have to collect the credential. When they come back from the external provider, though, they do need to have an authentication session in your app. So notice we still have to use cookies, because the result of the external authentication, that's just like a one-time handshake, and as that's complete, you want to keep track of the user. So the external authentication will result in a cookie within your application. So we have to have cookies, and then we add OpenID Connect. There's a bunch of coordinates you have to configure to make that protocol work, okay? And now what will happen is you want the cookie to be read on every request. So notice we've marked that as the default scheme, okay? But when you call challenge, like if you have the authorize attribute, authorize is going to trigger the default scheme. We don't want to do cookies because the whole point of this is not to have a local login. So when you configure these defaults, you can actually have a default that's different for one of those 5 different methods. So when the internal system calls challenge, which is what the authorize attribute does, it'll instead trigger the OIDC one, and that sends the user out to OpenID Connect. But when it comes back and issues the sign-in method and the sign-out and the reading of every request, it'll use cookies instead. So it's a nice little way to kind of mix both together. All right, I have a demo for all this, so I'm leading up to it. I have to show you all the parts, and then I'll show you the demo. The last thing that you might be aware of is for APIs. The typical approach for securing web APIs is using a token-based architecture. So we typically use something called a JWT or JOT, as the pronunciation goes. And basically, your web API, I actually highly encourage you to set up your web API in a separate project. Just keeps it cleaner, okay? Now, the web API project, you only have JOTs in your pipeline in terms of authentication, and Microsoft provides a handler for JSON Web Tokens using called the JOT bearer authentication handler, okay? So that's how you might protect your APIs. So I have a demo of this. So this demo has actually many, many moving parts of a whole bunch of things I just talked about. So the first thing is the startup code. The startup code basically is where we say, yes, I want to do cookies, right? So I'm going to do local session tracking, but I want to log my users in externally using OpenID Connect, okay? So I have those configured, and I show you the default scheme is cookies, but the default challenge scheme is OpenID Connect, like I just talked about. I have a home controller, right? When you come in here, yeah, you can be anonymous to come here, but when I click the secure link, authorize says I need a logged in user. So authorize internally, it calls the authentication system, and it calls the challenge method if the user's not authenticated. And that's where we get back to this, where it says, oh, I'm calling challenge. Who do I trigger challenge on? Oh, that guy, OpenID Connect. Okay, run this. And that says go elsewhere to go log in, okay? When this thing comes back, it issues a cookie using the sign-in method. Sign-in gets called, and it triggers the default cookie, and then we'll have a cookie in our app. And then when we go to the secure page, what I'm showing you here, once we finally make it all the way back, I'm showing you the claims that are in the cookie, and I'm showing you that dictionary. Remember I said the cookie has the claims and that dictionary of key value pairs. So let's just run this and see if this bit works. Okay, I hit my secure link. Okay, I'm in localhost 3308. Now I'm out, right? I'm off in some other website, which is my identity provider. That's where my users have their credentials. Right, so I'm going to log in with Alice and Alice, right? If the web is working today. That seems slow. Very, very bizarre. Can I go to Google? Okay. Okay, weird. It's hosted in Azure, so. Okay, allow, and we come back. All right, so basically we completed the workflow. What ended up happening is as a result of all of that, notice now I have a cookie called cookies, which happens to line up with the name of my authentication scheme that I was calling it here, right? If you could set up name, you would see the name here. And notice what's in the cookie then is we have a bunch of claims. These are the claims that came back from the external identity provider. We have a bunch of properties with a bunch of junk in here as well. And the thing I want to show you is look how quickly we got above 4K, right? Just with that little bit of data, right? So that's actually pretty easy to get up there with just a few more claims. Okay, the other thing I want to show you then is that this app wants to call an API, right? I need a token for that, right? That's the architectural pattern these days. So it turns out that when I was requesting a login from my login provider, I was also asking for access to this API. And so what ended up getting back was, in addition to all of the identity information about the user, like their name and their email and so on and so forth, I now have this thing called an access token. And the access token, if we pop open a website called JOT.ms, pop that access token in there, notice we have this JSON data structure. That's where the J in JOT comes from. It's a JSON object that is digitally signed by the token server, and it contains claims about my user. So my subject identifier, which is the most important thing about the user, that's the user's unique ID. If I go back to my login app, if I go up here, yeah, sub1, that is Alice's unique ID, okay? So I can use that now to call an API. So what API do I want to call? Well, I have another project here called API. Let me run this guy. So it's another project in Visual Studio. I go to my startup for this guy, and notice I'm then using authentication, but in this case, I'm only accepting tokens. I'm accepting JOT bearer tokens, and it should come from that same login provider that my app just used to log in the user. Okay? So now when I go back to my app, wherever it was, and I call my API, I want to, this is a request into my web server. The web server then has to make another network hop to the API. So it's a server-to-server call from the server-side MVC to the web API server, but I want it to be on behalf of the user, and that's why we're using that token. So if I go into the home controller, when I call the API, I can reach into the cookie that has the dictionary. I can ask for that access token. I create an HTTP client, and I'm setting the bearer token. I'm setting this as the authorization header when we call to the web API. And that authorization header is going to contain, basically, wherever it went, this JOT information. When it shows up the web API will decode that, validate it, and know who my user is. So if I hit the button here, here we go. So that basically called the web API successfully, I got the results back, and we're just echoing back what was in the access token. So the web API saw that the user's unique ID was 1. Okay, questions about that? Yep, question.
I noticed your audience claim was an array.
Yep.
It contained the API, which was the scope that was specified.
Yep.
Is that something new I'm used to in my APIs, verifying the scopes and not the audience?
Yeah, so there's a little bit of history there and maybe a little bit beyond the time we have to talk about here to answer the question. The question is, why do I have this audience thing and this scope thing? They're actually pretty much the same thing. As long as you're validating one of them, you're good, okay? Come and grab me afterwards and I can give you the history behind why we have two. It's basically because they're two different specs. And one spec says you have to do one spec says you have to do the other, and I'm actually using both specs at the same time, so I have to satisfy both, okay? Okay, cool. Questions, other questions? One other issue with access tokens is that access tokens expire. Right? If you scroll down here a little bit, it's going to say, hey, your access token is going to expire in some amount of time. Usually it's about an hour. So the problem here is that now you're calling on your MVC app over to the web API, you're calling the API, it works, and then all of a sudden you get a 401. And 401 means, hey, your access token's no good anymore. You have to go get a new access token. And I think we lost our projector here. So what do? Well, we need to go and somehow get a new access token. Now, what I don't want to do is redirect my user in the main browser all the way and come back. So the protocol has something called refresh tokens. And a refresh token is a way you can programmatically go back to the token server from your MVC app and get a new access token, okay? Great. Well, you have to write that code, unfortunately. Microsoft doesn't provide anything. So what we've done here as a kind of a nifty little sample is we have this little addition called add automatic token management. What's happening is this is just some extensibility points or taking advantage of the extensibility points of the cookie. And what it's registering is, remember how I said the cookie raises events, the cookie handler? We're tapping into those events. And remember the validate method? That's where the user has been validated from the cookie, right? You get to look at the claims, okay? Before the rest of the request goes. So we're not doing it necessarily to reject the user, but what we're using this for is a hook. Every time the cookie comes in, I'm actually extracting the tokens from that cookie. I'm looking for my refresh token. I'm checking for the expiration. And if my expiration is within near, some soon time, right, which I think we default to 1 minute, right? Yeah, nope, wrong one. There we go. Yeah, we're basically saying, hey, if we're within 1 minute of expiration, then let's go renew the token. So we basically go off and go back to the token server, get the results, and then what we do is we actually get the updated access token, and we update your cookie with the results, because we have to restore them, okay? So I've been talking for over a minute. This access token actually expires in 1 minute. So I'm gonna hit refresh here, and notice the access token should change, and the refresh token probably should change. So yeah, I hit refresh, they changed. That showed that this request coming in, right, triggered that, and said, oh, I need to go get new ones. So if I hit refresh right now, yeah, they're not changing. But if I wait long enough, I forget what the expiration is. I think it's 2 minutes. We should see it happen again. Yeah, there we go. Okay. So the point is, this is illustrating the usage of the events off of the cookie. We also do this at sign-out time. We're handling the sign-out time of the cookie to go and revoke the token as well from the token server. So nice little demo, kind of showing all these little pieces all working together in one application. Okay, I have 15 minutes left, so I gotta hurry. The next feature is the authorization feature from ASP.NET Core. So the authorization feature is completely rewritten in ASP.NET Core, mainly to move away the role-centric model of the prior ASP.NET. So you're familiar with the role-based approach where you put authorize and you put a comma-separated list of roles, right? That's very coarse-grained, doesn't give you a lot of fine-grained control. The comma-separated list is now your logic, right? If you have that logic in more than one place, you got to copy that all over the place. I had a customer who they had that authorized attribute everywhere, that whenever they had to change to their logic, they actually couldn't go find it all. So they actually wrote a tool to read their entire code base, find the authorized attribute, find the role they were talking about, and then rewrite all their code out with the new value. If you're doing that, something's wrong, right? So this authorization framework that's new in ASP.NET Core is called policy-based authorization, and it's actually quite nice because it helps point us in the direction of a better pattern, okay? The better pattern is basically just giving us a level of indirection. Okay, so this isn't quite rocket science, right? It's what we use in computer science to solve any problem, except for performance, of course, is we put a level of indirection in. So notice at the bottom here, I have the authorized attribute. It does not have a list of roles. It has kind of like a permission name called manage customers. That is using the new policy system. It basically says the user has to satisfy this policy called manage customers to get into the method, okay? Well, where's the policy? It's not here. Well, that's what the code in the top left is. The code in the top left is basically creating a policy. So we're adding the authorization services to DI. We are creating a policy called Manage Customers, and a policy is a list of requirements. The requirements are things that the user has to satisfy the entire policy. So there are 3 requirements, and the user has to satisfy all 3. The first one is, of course, the user has to be authenticated. Okay? You have to be authenticated to get in, sure. You also have to have a claim called department sales, and you also have to have a status of senior. And if one of those doesn't match or doesn't pass, you failed the policy and you get rejected from the method. Okay? The beauty here now is my logic is in one place. If I choose to change the rules change about who can manage customers, I have one place to do it. Right? I don't have to go and search through my entire code base for everywhere I use that role, for example. Also, we can call this programmatically. The authorization service is actually a service in DI. So instead of just using the attribute, you can do this programmatically. So you can do this within your code, right? This actually makes your action method unit testable, if you wanted to do it this way. This also allows you to call the logic from multiple places. And imagine in your UI, you want to hide the button if you can't manage customers, but you also have to enforce it on the postback. Right? So those are 2 different places that need the one chunk of logic. So this gives you the ability to do that. Also, policies themselves are unit testable. So you can actually just test the policy and make sure that it does what you want independent of the rest of the application. Especially then if you choose to change it in the future, you run all your unit tests against your policy. If anything breaks, well, you've broken the logic. The policy-based system then can get even more advanced or sophisticated. So the way this demo works here, or the way the sample works on the slide, it kind of leads you to think that policies only work against claims that the user has in the cookie, for example, okay? And that's not true. Claims are meant to model the user's identity information, not their permissions, okay? So the identity information is an input into your policy, sure, and if your policy can satisfy its logic by just looking at that identity information, you're good to go. But very often, your authorization logic might need other sources of data. Right? The user is an input, but who that user is, I need to go look up in the database more information to find out if they're allowed to do something. Okay? Like I said, you don't want to put 1 million permissions into your claims because your cookie will get too big. So, how's that work? Well, the policy-based system has the ability to create what's called a custom handler. Basically what this is you can create your own requirement. And a requirement is just a concept. It can have some data with it if you want, or not anything at all, it doesn't really matter. But the whole point is you create this concept of a requirement. So I've created this job level requirement. You then create the logic or the class, the handler that knows how to check that requirement. And this goes in the DI system. Now that this is in the DI system, at runtime, when this requirement is being executed, this is resolved from DI, which means this class can resolve other things from DI, like your organizational service, or a DB context, or an HTTP context to call a web API. And now in this handle method where you implement your logic, you're handed in this context that has the user, so that's the user with all their claims from the cookie typically, and you get the requirement object. That may have some additional data for you to do your logic. And then you can call out to your database, call out to your services to help get the results that you need to say you like the user or you don't. And if you do, you call the succeeded method, and that means that this handler or this requirement has been satisfied. Okay? That's the idea with this. So we're putting levels of indirection for more testability, composability, things like that. Okay. So yeah, I think that the takeaway here, if you weren't aware of this, is that claims are typically not for permissions. Okay? They're for identity information, and that's an input to your authorization, which maybe then goes and looks out elsewhere for permissions. Okay? So there's one last style, and again, I'll go quickly because I'm running out of time, is that there's the next sort of level of sophistication of this policy-based authorization is resource-based authorization. So far, kind of up to this point, you're only looking at the user to see if they're allowed to do something. Well, what if the logic is, it depends on the user, what they're trying to do, and what object they're trying to do it to. Okay, so the typical example is Brock is trying to delete a document. Okay, does Brock have the rights to delete that document? Maybe, maybe not. So I probably have to go look up the document to find out. So that's the concept of resource-based authorization. Same idea. You basically build a handler, just like the prior one, except this handler takes, in addition to the user as an input, you take the operation, right, what the user's trying to do, and you then take the resource that the user's trying to operate against, in this case, like a document. And then you go sort it out with whatever your logic is, you say succeed, and the user can get in and do it. Okay. So this is what it would look like to invoke that. Again, same authorization service that I mentioned that's in the DI system. You authorize, pass the user, the document, and the operation, and it says yay or nay. Okay, oh, I forgot about this one. So another, probably a topic that could totally be a whole day on its own is ASP.NET Identity. This is a whole other set of services provided by Microsoft, which has to do with managing the database that holds your user information and, more importantly, the credentials for your user. So all the stuff about session management and cookies and all that, that's an important piece. That's the authentication piece. But if you are collecting credentials and want to validate a username and password, you need a database for that. So that's, strictly speaking, what ASP.NET Identity is for. It's really just a fancy wrapper around the database and some password hashing, and it does things the right way. This is something you don't want to build on your own from scratch. So this will manage the record in the database for your user, their password, email for doing password resets. They have a whole workflow for validating the email to make sure it's really the right email. They support multi-factor authentication, so they have things for onboarding multi-factor devices and validating those. and dealing with lost multi-factor devices. For the login workflow, it helps with brute force protection. I actually had a customer this Monday during the workshops who was being brute force attacked, and they were like calling me up. They're like, what's going on? What do we do? And I said, well, you're okay, because none of their users got compromised because the brute force protection was kicking in and locking out those attempts. Okay? It also deals with creating a record for your user that maps from an external login. So if you do have Google logins or OpenID Connect logins, when the user shows up in your app, you still need a record for that user, even though you don't have a password. So it helps with that as well. Okay? So again, this is the library that you should probably use to be managing that record for the user in the database. Okay? If you are using this, then there is a bridge to then issuing your cookie. Right? So if you do have the login page, you call this to validate the password, but then you of course need the cookie to be created using the authentication system, and then that's the last piece there, which is something called the the sign-in manager for issuing cookies and deleting cookies. Okay. So the last piece here in my last 4 minutes is those are a lot of really good features provided by ASP.NET Core to build that architecture that I had mentioned at the beginning. Okay? There's actually a missing piece though, right? There's lots of really good components in there for doing external authentication, right? Getting a token back, validating the token like with OpenID Connect, and using the token to call the API and validating a token at the API. So those components consume tokens. The thing Microsoft is missing is something that produces tokens. In other words, a token server or something that is your single sign-on server. Now, Microsoft has lots of products that do this, right? Azure Active Directory, B2C, and things like that, but there's nothing in the box that lets you do your own, okay? Well, until ASP.NET Core 3.0. I mentioned at the beginning of this session, I work on an open source project called IdentityServer, and it basically allows you to build your own single sign-on server. People use this typically in your application architecture to set up your own token server, your own single sign-on server, to abstract all of your apps from the details of logging in. And that includes passwords, but it includes maybe federating with Azure Active Directory or a business partner. Okay? So Microsoft's actually now going to be shipping this in the templates in Visual Studio. So basically, it's I have a VM here somewhere. There we go. And this VM it has the Visual Studio 2019.1 or whatever preview, so it's the preview for ASP.NET Core 3.0, okay? And what I have done is I've done a file new project, and I did the SPA template, and the SPA template, I went to the checkbox where it says, I want authentication for my APIs. That's basically been missing from their template story all the way since ASP.NET Core was shipped, or released. So we've been working with Microsoft to figure out how to have them use our NuGet package, and they are building their own little abstraction over our configuration system to kind of give you a zero config where you can have IdentityServer in your project, protecting your APIs, issuing tokens, but with you not having to really think too much about it. Okay? So the way this works is we go to Startup. Here's ASP.NET, that's the DB context for ASP.NET Identity. Here's the code for ASP.NET Identity. That's the database, password management stuff. And here is where they're adding IdentityServer. This is just our extension method directly from our NuGet package. They then are wrapping up with this Fluent API their one-liner of configuration, if you will. Their configuration, I believe, is driven by what's in JSON. So you can go and set up more client apps and things like that here. Maybe you want a mobile app and a SPA and a desktop app or whatever. So you can set those up in here. And then this project also is hosting an API. So the API that's co-hosted with your login page, that's co-hosted with IdentityServer, wants to validate tokens from that same IdentityServer. So that's what those two lines do there. So if we run this, so this is their new Bootstrap 4 template. I will go here to log in. And I know it's kind of hard to see, but if you look up here, you'll see this return URL is connect, authorize, client ID, redirect URI. There's some scopes in there. If you know the OpenID Connect and OAuth protocols, those terms will be familiar. So the point is, under the covers, they're hiding IdentityServer, and I guess you'll just have to take my word for it. It's there, okay? So then when I log in with Brock, 1, 2, 3, come back here, and I go to my, let's open up my network tab here, and go to my fetch data page. Notice what happens is, actually I can show you this, is that, sorry, wrong place. This fetch data call, what it ended up doing is an AJAX call back to the web API, and in there is, hey, look at this, the authorization header. There's a bearer token, and that is a JSON web token that is coming from the identity server that you guys almost didn't even see there, right? So it looks like the old ASP.NET identity templates, but under the covers, they're actually making the SPA communicate formally with the token server that's co-hosted. You get tokens back, and those tokens are being used to call the API. Tokens are a great way to call those APIs because it helps you with the cross-site request forgery problem, right? You don't have to do your anti-forgery stuff. This encapsulates both authentication and anti-forgery in one credential format. Just other quick thing here is if I remember where they put the JavaScript code, the other thing they're doing is they're providing, this is actually the Angular template. They do the same from the React template, is that they're pulling in this JavaScript library, which is the open source JavaScript library for SPAs to do OpenID Connect. Okay? So they're wrapping that up, and that's, all the protocol work is really happening in that library. This template is just kind of wrapping it up into a Angular service that makes it a little easier to use. Okay? And then they have an interceptor for their outbound HTTP calls. And what the interceptor is doing is pulling in that authorization service. And in the authorization service, they're getting the access token. And then what they're doing is they're popping in the access token here into the authorization header using the bearer scheme. Okay, so anyway, it's in there. It's kind of cool. They've been, working on this for a long time. So it's kind of cool to see IdentityServer now there in ASP.NET Core. Okay, so that should be coming out in 3.0. In addition, they have other workflows that they're going to be supporting, like server-to-server API scenarios as well, and in the future, they'll be expanding that more. So this is just the first step towards that. Okay, other than that, that hopefully gives you an idea of a lot of the features in ASP.NET Core to allow you to build secure, modern ASP.NET Core applications. Thanks for having me, and by the way, I have IdentityServer stickers up here. I have a whole bag of them for all 4 of you. So if you want to come grab a sticker, you can. Other than that, thanks, and enjoy the party tonight.